In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a partner, a family. Please subscribe and share our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your precious time. Okay, today I'm going to discuss my lecture number 40. Oil and gas production, exploration, production, upstream, midstream, refining, petrochemical, differentiated performance, enabling profit optimization, lecture number 40. Before my lecture, I used to read a Quranic verse. Qala Rabbi shrah li sadri wa yassir li amri wahlul uqdatam min lisani yafqahu qawli Allahumma Rabbi zidni ilma. O my Lord, open my chest and ease my task for me, and loose a knot from my tongue that they may understand my saying. Allahumma Rabbi zidni ilma. O Allah, advance me in my knowledge and true understanding. Thank you very much for your precious time. Okay, I have also provided my WhatsApp number at the end of my presentation. Please send me your input or feedback through WhatsApp number as well. Okay, oil and gas production. Oil and gas production, introduction, facilities and processes, resources, wellhead, management system, upstream facilities management systems, midstream facilities management system, refining facilities management systems, petrochemicals, utility systems. Now we are discussing unconventional, conventional resources and environment effects. Okay, what is ultimate goal? Shaping the clean and sustainable global energy delivery. Planned to deliver a more than 300 lecture next couple of years. Okay, oil and gas productions, conventional and unconventional resources and environment effects, lecture number 40. Today we have planned to discuss shale gas and coal bed methane, coal gas to liquid and synthetic fuel, methane hydrates. Okay, from the next slide we will discuss a key takeaway points. Okay, key takeaway points from lecture number 40, shale gas, coal bed methane, coal gas to liquid and methane hydrates. Okay. Shale gas and coal bed methane. Oil shales are also becoming an important source of shale gas, and some analysts expect that this source of natural gas can supply half of the gas consumption in the US and Canada by 2020. Shales normally do not have the required matrix permeability for the gas to be produced. And in the past, gas could be produced only from the source rock with significant natural fracturing. The natural gas comes from decomposition of shale oil and is held in natural fractures, some in the pore spaces and some absorbs onto the organic materials. Recently, there have been strong advances in the extraction technology, which uses a combination of horizontal wells and hydraulic fracturing in a way that maintains fracturing and flow of gas much better than the before. Even so, production typically requires a high number of wells with limited lifetimes, so the continuous drilling of new well is required to maintain output. Methane is a potent greenhouse gas, and emissions from leaking capped wells and fractures is a potential problem due to large number of wells. Okay, this form of production is different from oil shale gas, which is produced by pyrolysis. Pyrolysis means heating and hydrocarbon decompositions of mined oil shales. Coal deposits also contain a large amount of methane, referred to as a coal bed methane. The methane is absorbed in a coil matrix and requires extraction technique similar to the shale gas. Often the coal bed is flooded, so after well completion and fracturing, the coal seams layer of coal must be dewatered. A common solution is to extract water through the well tubing. Generally, the water needs to be pumped out and therefore control is needed to prevent the gas from entering the water in the tubing. This is also known as the well becomes gassy. This reduces the pressures and allow the methane to absorb from the matrix and be produced through the casing. Okay, as per US Energy Information schematic demonstrate over here. Okay, so the first, if you can see here, it is a conventional and non-conventional associated gas, this area. Okay, and here this area is containing the conventional associated gas, and this is the coal bed methane, and here is the land surface. Okay, so this is a sealant, this is the sealant here, and this black line over here demonstrate here the gas rich shale. Okay, this is the sandstone here and a tight sand gas here. Okay, so this schematic demonstrate the position of shale gas and coal bed methane. Okay, coal gas to liquid and synthetic fuel. Coal gas is similar in origin to oil shales but typically formed from the anaerobic decay of peat swamps and relatively free from non-organic sediments deposits, reformed by heat and pressure. To form a 1 meter thick coal layer, as much as 30 meters of peat was originally required. Coal can vary from relatively poor carbon to carbon soaked with hydrocarbon, sulfur, etc. Okay, it has been known for decades that synthetic diesel could be created from the coal. This is done first by creating water gas as a synthesis gas by passing steam over the hot coke. The reaction is endothermic and requires heating, which we're going to discuss in my next slide. So if you want to know more about the synthesis gas, please follow up on my other lecture 34, 35, 36, 37 about the synthesis gas. Okay, it has been known for decades that synthetic diesel could be created from coal. This is done first by creating water gas as a synthesis gas by passing steam over a red hot coke. The reaction is endothermic and requires heating. Okay, so in chemical reaction over here, so the carbon here reacted with steam here, so it will produce hydrogen plus carbon monoxide. Okay, more hydrogen is produced in water gas by shift reaction. What is a shift reaction? There is a two types, HTS, high temperature shift converter, and LTS, low temperature shift converter. Okay, so the further carbon monoxide reacted with further with steam here, and it produced hydrogen and carbon dioxide. Okay, so the carbon dioxide is easy to remove through absorber. That is, this process is used in the ammonia plant. Okay, often two stages are used: a high temperature shift converter HTS at 350 degrees Celsius with catalyst iron oxide prompted with chromium oxides, and low temperature shift converter LTS at 190 200 degrees 210 degrees C with catalyst copper on a mixed sport composed of zinc oxide and aluminium oxide. Okay, these synthesis gas are then used in the Fischer-Tropsch process, which I'm going to discuss in my next slide. Okay. Okay, coal gas to liquid and synthesis fuel. So these synthesis gas are then used in the Fischer process here. The first here are 2N plus 1 hydrogen, then a plus N carbon monoxide. So what you produced? CN and hydrogen. So it will be 2N plus 2 and plus N H2O. Okay. So it will produce here. So the N number of molecules, carbon monoxides, carbon molecules, and hydrogen molecules over here, as it demonstrates here. Okay. This process runs at a pressure 2 to 4 MPa megapascal with iron catalyst at high temperatures of process at 350 degrees Celsius. Will yield diesel fuel quite similar to the normal diesel with an average carbon number of 12 and a certain content of unwanted aromatics. The low temperature process uses a cobalt catalyst and temperature of 200 degrees Celsius and yield a pure synthetic diesel composed of alkenes with a carbon number of 10 to 15 and an average carbon number of 12. Okay. A coal gas to liquid and synthetic fuel. The synthesis gas can also be created from natural gas by lean combustions or steam reforming. Okay, first, if we can see here, this is my methane gas, CH4 plus half O2, and it will produce here carbon monoxide plus 2 hydrogen atoms to balance equation. It's called lean combustions. Okay. Further, for the steam reforming here, CH4 here plus hydrogen, H2O, steam here, and it will produce carbon monoxide and 3H2 hydrogen. Okay, this is steam reforming. This can be fed to the water shift reactions and to the FT process. This process, together with the application, are often called as the GTL process or gas to liquid process. Okay. An alternate use of synthesis gas, CO plus hydrogen, is productions of methanol and synthetic gasoline, as we are going to discuss on my next slide. Okay, coal gas to liquid and synthetic fuel. An alternate use of the synthesis gas, carbon monoxide and hydrogen, is production of methanol and synthetic gasoline. Okay, first it will react with a 2 hydrogen atom plus carbon monoxide. It will produce methanol CH3OH, methanol synthesis. Okay, then the methanol is converted to synthetic gasoline in the mobile process. 2 CH3OH converted to CH3OCH3 plus H2O. Dehydrations to dimethyl ether. The second stage further dehydrates the ether with solute catalyst to yield a synthetic gasoline with 80% carbon number 5 and above. Okay. This is my last slide. Methane hydrates. Methane hydrates are the most recent form of unconventional natural gas to be discovered and researched. These formations are made up of a lattice of the frozen waters, which forms a sort of cage around molecules of methane hydrates, were first discovered in permafrost regions of Arctic and has been found in most of the deep water continent shelves tested. The methane originates from organic decay at the sea bottom under high pressure and low temperature. The hydrates is heavier than water and cannot escape. Research has revealed that this form of methane may be much more plentiful than first expected. The estimate range anywhere from 180 to 5,800 trillion square meters. The US Geological Survey estimates that methane hydrates may contain a more organic carbon than all the world's coal, oil, and conventional natural resources. Okay. However, research into methane hydrate is still in its infancy stage. Okay. Conclusion. Today we have discussed shale gas and coal bed methane, coal gas to liquid and synthetic fuel. Methane hydrates. Okay. My next topic we are going to discuss biofuels and hydrogen. Okay. References here. So the Qatar Petroleum, Doha, Qatar, OGDC, Pakistan, World Energy Outlook 2013. So US Geological Survey, US Department of Energy, Schellenberger's Oilfield, International Energy Agencies, Wikipedia, Oklahoma State Oils, State Oil Fact Sheets, No.16, the story of the oil in Pennsylvania. So the liquid gas encyclopedia, the natural gas from wellhead to burner tip. These are the references. Together, everyone achieve more. Please do not hesitate to send me your input, feedback through my email dusty.masood.dr@bath.edu or WhatsApp. I have also provided my WhatsApp number. Please stay at home, stay safe, inspired, and blessed. Thank you very much for your precious time.